Have you ever just looked up at the night sky and wondered, what are we, really? I mean, what are we actually made of, and where did all this stuff come from? Well, today we're going to find out. We're taking a journey across billions of years and deep into the hearts of dying stars to answer that exact question. Let's dive in. Okay, so let's start right here with the ground beneath our feet. If you could take our entire planet and break it down into its ingredients, this is what you'd get. The biggest slice of that pie, a whopping 35%, is iron. Most of that's way down in the Earth's core. Then you've got oxygen, silicon, and magnesium, which make up most of the rocky parts, the mantle and the crust. But is this what we're made of? Now, let's look in the mirror. This is the recipe for a human. And it is a completely different story. Oxygen is the undisputed champ here at 65%. Then comes carbon, the absolute backbone of all life, and hydrogen, which is in every single molecule of water in your body. So clearly, we're not made of the same stuff as the Earth as a whole. And that brings up a really interesting question. I mean, think about it for a second. Right after the Big Bang, the universe had basically cooked up only the two lightest, simplest elements there are, hydrogen and helium. That's it. But look at us. Look at the planet. We've got carbon, oxygen, iron, all this complex, heavy stuff. So what happened? What happened between the dawn of time and right now to create the building blocks for planets and people? The answer, and I mean this quite literally, is written in the stars. Every single complex atom, pretty much every bit of matter, heavier than helium, was forged inside the fiery heart of a star. Stars are the universe's element factories. They take the simple leftovers from the Big Bang and cook them into the rich, diverse elements that make everything possible. So if we want to understand ourselves, we have to start by understanding the stars. So how do you build one of these incredible element factories? Well, it all starts in these vast, cold clouds of dust and ends with a whole lot of fusion. It's kind of like a four-step recipe. First, you get a big, dense clump of gas and dust, what we call a nebula. Then, gravity, the master sculptor of the cosmos, starts to pull everything inward. As that cloud collapses on itself, the pressure and the temperature just skyrocket. That glowing baby star is called a protostar. And finally, when the core hits a mind-boggling 10 million degrees Kelvin, a brand new kind of fire ignites. And that fire is called nuclear fusion. This is the engine that powers a star. Deep in the core, the pressure is so intense that hydrogen atoms are smashed together, fusing to become helium. This whole process unleashes a tremendous amount of energy. That's the star's light and heat. And most importantly for our story, it's literally turning one element into another. It's cosmic alchemy, and it's happening in stars all across the universe. But here's the thing, not all stars are created equal. As we're about to see, their entire life story and the elements they're able to create all comes down to how much they weigh. So there are really two main paths a star can take. On one side, you have your average stars, kind of like our sun. They live for billions of years, and they're pretty good at forging lighter elements, like carbon and oxygen, before they eventually retire as a quiet little white dwarf. But then you have the heavyweights, stars that are more than 10 times the mass of our sun. They live fast, die young, and can forge elements all the way up the periodic table to iron before going out in the most spectacular explosion imaginable. Let's look inside one of those sun-like stars first. For most of its life, it's just humming along, steadily fusing hydrogen into helium. But when the hydrogen in the core finally runs out, things get interesting. The star swells up into a red giant. This dramatically cranks up the heat in the core, getting it hot enough for the next step, fusing helium atoms together to create carbon and oxygen. Just the fundamental building blocks of life. Okay, but inside a massive star, things are way more extreme. Its incredible gravity creates pressure and heat that are just unimaginable. This allows fusion to keep going in multiple stages, kind of like the layers of an onion. Hydrogen fuses to helium, helium to carbon, carbon to neon, and so on, creating heavier and heavier elements until the very heart of the star is nothing but a dense ball of pure iron. And this is where the production line grinds to a catastrophic halt. See, iron is a uniquely stable element. Trying to fuse it doesn't release energy. It actually consumes energy. The star's engine, which has been pushing outward against gravity for millions of years, suddenly just shuts off. With nothing holding it back, gravity wins, and the core collapses in less than a second. What happens next is the most violent and also the most creative event in the universe. Because the death of a massive star isn't really an end. It's an incredibly powerful new beginning. We call this event a supernova. That collapsing iron core basically bounces back, sending a shockwave of unbelievable power blasting out through the rest of the star, completely tearing it to pieces. The energy released in that single moment is so immense that the explosion can briefly outshine all the other billions of stars in its galaxy, combined. A supernova gives two absolutely vital gifts to the universe. First, it acts like a cosmic seed spreader, blasting all those elements forged during the star's life, the carbon, the oxygen, the iron, all across space, enriching the galaxy with new material. And second, the sheer energy of that explosion is finally enough to overcome the iron problem, forging all the elements heavier than iron in a flash. The gold in your jewelry, the uranium that powers a nuclear reactor, all of it was created in the final, violent moments of an exploding star. So now we've got a galaxy seeded with all the elements of the periodic table. Let's fast forward in time, move to our own cosmic neighborhood, and see how this stardust builds a home. Around 5 billion years ago, the shockwave from a nearby supernova probably kickstarted the collapse of a fresh cloud of gas and dust, a cloud that was already enriched with the leftovers from previous generations of stars. And the process repeated itself. Gravity pulled most of the material to the center to form our sun, while the rest flattened out into a spinning disk. In that disk, tiny grains of the stardust started sticking together, growing into bigger bodies called planetesimals. And over millions of years, they collided and merged and built up the planets we know today. Now, the early Earth was a pretty violent place. All those constant collisions made it so hot that the entire planet was just a giant ball of molten rock, a magma ocean. And in this hot mess, the elements started sorting themselves out. The really heavy stuff, like iron and nickel, sank down to form the core. Lighter materials floated to the top and eventually cooled to form the mantle and crust. And then it rained, and rained, for centuries, condensing to form our oceans. So we've come all the way from the Big Bang to the formation of our planet. Now it's time for the final, most incredible connection of all, bringing it all back to you. When you look at your own body, you are looking at a living history of the cosmos. The hydrogen in the water you drink, that's the original stuff, straight from the Big Bang. The carbon that forms the very structure of your cells, and the oxygen you're breathing right now, that was all forged in the core of a medium-sized star that lived and died long ago. And the iron in your blood, the very atom that carries oxygen to keep you alive, was created in the heart of a massive star and flung across the galaxy in a supernova explosion. This isn't just poetry, it is a literal scientific fact. The late great astronomer Carl Sagan put it best. He said, "We are all made of stardust." The universe isn't some distant thing we look at. We are a part of it. We are a way for the cosmos to know itself. So, the next time you look at your hands or you gaze up at the night sky, remember that you carry the legacy of exploded stars and ancient nebulae within you. You are a piece of the universe that has become self-aware. So the real question is, what will you do with that incredible inheritance?